The Module 2 test is over. We are now going to go more in detail on stock naming. That's naming that involves transition metals. Okay, so most transition metals exhibit multiple oxidation states. That is due to those d electrons that can shift. It's like having a Heidi pocket where they have extra electrons that aren't in bonding until they want them to. So d electrons that can shift. So for example, iron has two oxidation states, iron plus 2 or plus 3. It is in between um, group 2 and group 13. But the reason it has these oxidation states goes back to its electron configuration. So if we look at iron plus 2, we've got our 4s and our 3d. Iron typically, right, would be 4s2, 3d6, but if it lost 2 electrons, it's going to lose those from the 4th energy level. And so our 6 electrons are going to be here in the d. Those 4s electrons are used for bonding, and that's what gives iron that plus 2 oxidation state. Looking at that configuration, we can kind of see where iron gets its plus 3 oxidation. Again, if it was a plus 3, it would lose another electron. It would relieve that electron-electron repulsion in that first orbital, and you will have single electrons in that 3d, because it would become none in the 4s and then 3d5. So that also makes a very stable configuration for iron. Both of these are very stable, and that's what we're going to use to justify why iron has these plus 2 and plus 3 oxidation states. To tell oxidation states apart, we use Roman numerals. Okay? So for example, iron with a Roman numeral 2 refers to iron plus 2, and iron with a Roman numeral 3 refers to iron plus 3. If we go name to formula, if I give you a name and I'm asking you to write the formula, all you have to do is remember that those Roman numerals are the charges on those metals. So iron 2 oxide would be symbols charges, right? So Fe with a plus 2. Oxide would be O with a minus 2. Those are electrically neutral, and so my formula would just be FeO. But what if I had iron 3 oxide? Iron 3 oxide, I would have Fe with a plus 3 and O still with a minus 2. Crossing my charges, I get Fe2O3. So there's a difference in the formulas for iron 2 oxide and iron 3 oxide. Formula to name. So if I gave you the formula and asked you to give me the name. The most important part on this is remembering that you've got to find the Roman numeral. Finding the Roman numeral, that comes from the charge and number of anions. The anion's charge doesn't change, and so that anion can give you the clue and how many of those anions do you have to find the Roman numeral of that transition metal. So our first example here is CuClO3. My L got a little squished, I apologize. So Cu is copper. Copper is a transition metal. ClO3, I look it up on my chart, and that is chlorate. To find that Roman numeral, I need the charge and number of anions. Chlorate is a minus 1, and there's only 1 there. That makes copper a plus 1, and so a Roman numeral 1 will go for my transition metal. Let's do the next example. We've got PbS2. So Pb is lead. Lead is not a transition metal. It's in the carbon family, but it still has multiple oxidation states, therefore it gets Roman numerals. S is sulfide. Sulfide's charge is a -2. If I have 2 -2s, that gives me a total of a -4 charge for my anion. Therefore, lead, to neutralize it, must be a +4, and a Roman numeral 4 will go next to that lead. SN, C2O42, SN is 10. Like lead, it's in the carbon family and it gets a Roman numeral. O2O4, C2O4 is oxalate. Oxalate has a -2 charge when I look it up on my sheet. 2 -2s, just like that sulfide, makes this 10 a +4, and therefore that would be 10,4 oxalate. Then our last example is nickel. Nickel is also a transition metal. SO3, look it up on your sheet, is sulfite. Make sure you spell the ending correctly. Sulfite's charge is a -2. I only have one of those, so I need a +2 charge for my cation. However, because of this 2 here next to this nickel, I have to split that +2 so that each nickel contains a +1 charge, and so this would be nickel 1 sulfite. A great way to check yourself is to just go back from the name and write the formula and make sure they match. Copper 1 chlorate would be Cu with a +1, chlorate with a -1. Those are 1 to 1, and I get my formula. Lead 4 sulfide would be Pb with a +4, S with a -2. To neutralize that charge, I would need 2 of those -2s. Check. That matches. 10,4 oxalate would be SN, C2O4 with a -2. Protect what I copy, and then just like before, I need to double the amount of that negative charge to get a neutral compound. The last one, I've got nickel with a +1 charge, sulfite with a -2 charge, so when I cross that charge down, I get that 2 there. Check. I can always double check myself. Okay? Thank you guys so much for watching. Good luck on your PL assignment.